Hey, Mr. Ray. Can you hear me, Mr. Ray?
I had my thing on mute. I was wondering what was happening. Good day.
Okay.
Yes, I can hear you now.
Yeah. Hey.
Yes. Good evening. Good evening, everyone. How are you guys doing today?
Good.
Hey, Mr. Ray.
Yes.
More than just being a good teacher, I want to thank you for the encouragement that you extend, because it just makes a huge difference. Of course, it also takes footsteps on my behalf, but I just want to thank you so much, because it's just that much easier, and I feel way more comfortable, and I'm actually really happy that
That's good. I'm glad to hear that. You're welcome.
Thank you for the encouragement and putting it out there like that.
It's very encouraging to hear. So you're welcome, and thank you as well, because it really makes me know that I'm actually becoming what I want to be, somebody who can transform other people to do well.
That's awesome. Yeah. So thank you for your time and your intentionality and exhorting us and pushing us to do better.
All right, thank you, and I definitely will continue to do that. So thanks again, Jacob, for that.
I agree with
definitely
Jacob.
Encouraging.
I'm agree with Jacob too.
Thank you, Dorcas, and anyone else. I saw a thumbs up from you, Raymond, as well. So thank you. You guys can make me shed a tear.
Nice. Yes.
Yeah. So all right. So I'm just gonna start writing down your names as well, just so that I can ensure I have everyone.
Yeah.
So George and Jacob, of course, is writing down your name again.
Yeah.
And Sergio. And Susanna. Good day, Susanna.
Hello.
And Clemente.
How you doing, Mr. Ray?
Good to have you again, and good to know you're good and strong.
Yes, thank you.
And Raymond, again, just getting your name down now. William, Marisol.
Good evening, Mr. Ray.
Good evening. And Dorcas, and Salvador.
Here.
And Maria Mesa.
Here. Hi.
And Latavia.
Yes, sir.
All right. So it's good to have you guys all again. My apologies, I didn't get that video up. It took forever to download. So I forgot to do it over the weekend. As normally it could take some time depending on the internet and all that stuff. So I should have it up with this one when this one finishes. It shouldn't take too long once I get this one. So my apologies if you were looking for last week's video. So you'll see it stopped at the week before last. But nonetheless, you guys are like literally like one class now away from the other class. So like I said before, it kind of gets me a little bit confused with who is on what. And sometimes I think I've covered something with you guys, because it was easier before. You guys were behind, and that was because you started later. They started 2 weeks before you did. But you have caught them up. So you have come within 2 weeks of them. So I know we stopped on section, or lesson rather, 2. I know we had started lesson 2, but I don't remember how far we got on it. We were working on solving equations. Does anyone remember how far we actually got on that?
Yeah, Mr. Ray, I've copied some information from the maths from the equation that we need to go through.
Okay, so where were we? I know we did number 5. I wanted to say we had made it to number 9, but I don't recall doing number 9 with you.
Yeah, from my point of view, for the multi-step equation that you sent to us, I tried to do some example.
Okay, as you're talking about from the homework?
Yeah, I get lost somewhere. That's why I wanted you that we should do some sort of revision.
Yeah, I was gonna do that afterwards. I just wanted to know once you finished the homework, where was I starting? So quick question, does anyone remember if we did number 7?
Nah, not the triangle.
No,
Not number
we didn't.
7, Mr. Ray.
How about number 5? I remember doing number 5, but I wasn't sure if it was you guys or the other class.
No, you didn't.
No, we didn't. We
Okay,
didn't.
so we didn't really get that deep into this one, right?
No.
No.
Okay, so that means we were finishing off here, and I believe, okay, now I don't recall exactly where. So I'm gonna have to start writing it down. Before I didn't have to do that, but now that you guys are literally like right behind them, I'm gonna have to start doing that. So who remembers exactly where we left off? Does anyone have it, their notes?
Yeah.
And then I'll go straight to the homework. Because I know I gave you guys order of operations to work on and had sent some equations, but I guess we hadn't got to it, so.
I think we were just simplifying and solving equations, I guess.
Just the basic one. So we didn't get to the actual questions in the book.
No.
Oh.
Okay. All right. So with that, George, you said you had some questions regarding what we were doing in terms of the homework. So could you let me know which one in particular?
Okay, yeah, I have number 5 minus 4 is
Okay,
equals to
number
R.
5. Can you tell me the title? Because I sent you guys a few worksheets.
Yeah, for the one on the 5th, on the 5th November.
I mean, what's the title of the worksheet?
Two-step equation.
Oh, okay. So we're not on the. I don't think we've covered really much of the equations yet. So you don't have to do that one yet.
Okay, okay.
That's what we're going to start today, with more of the equations, how to do that.
Okay.
So, but let me just ask: did you guys know how to do the order of operations? Was that fine?
Yeah.
Okay. And how about the factoring part? I remember that's where we were having some issues last week, and I gave an easier one just to kind of build up everyone's confidence. These right here, were these okay?
Factorizing.
Yeah, sure.
Yeah.
Okay, and that takes us now to the solving equation. So from my recollection, we didn't get that deep into solving equations. I do remember talking about the order of operations.
Yeah.
And just trying to remember how much we did. So I'll definitely write it down this time.
Because you said in the other operation, from the weakest vessel, maybe from multiplication, from addition, subtraction, multiplication, division, then right up to parentheses.
Right. And then we did the opposite, and I'll show you guys how to do the solving step. And just want to make sure I don't skip anything important. No, that's not it. Okay. Okay. So this is it. Right. So we had gone over this right here. Right. We had gone over when we solve, we start from the weaker operation and work our way backwards. Do you guys remember that?
Yeah.
Yes.
Okay. And does anyone have the last example that I gave you guys on your notes?
Yes, sir. The last one I have is x over 3 minus 5 equals 7.
Okay, so that means your questions were correct there, George. It was this one here. So let me bring it up. So George, you had questions from number 5, you said, on this sheet?
Yeah, that is the question I was talking of.
Okay, perfect. So based off of what was said, I wasn't too sure exactly where I started. I knew I'd given you guys a flurry of work to try to do. All
Mr.
right,
Ray,
so, yes.
sorry, before you continue. Actually, I'm driving right now. I'm on the freeway. There's a lot of traffic.
Okay.
As soon as I get home, I'll log back in. Is that okay?
Yeah, that's fine. We're just
Okay.
going over the homework, and then we should be going on to the book stuff.
Okay, all right. I'm not
All
that
right.
far from my house, so I should be able to be pretty
Okay.
quick.
And
All
I got
right.
you,
Thank you,
Dave.
Mr. Ray.
You're welcome.
Mhm.
All right, so let's go ahead and check out number 5. Anyone wants to kind of lead us out on how to do this? All right, so let me go
With
ahead.
which one? I can give it a shot.
Okay, number 5.
Okay, so we're gonna simplify. So we do the opposite. So we identify the weakest operation,
Right,
and we choose that number. We just do the opposite of it. So in this case, we do the same to the other side of the equation. So we have -5. That would be our weakest operation. So we
right,
turn it into a +5 underneath, and we take that to the other side of the equation. Underneath the -4, we do a +5. So
right.
now on our right side, we cancel the 5s, and that leaves us with a -4 +5 equals +1.
Right, +1, and
And
maybe
then
right.
now we go to to r over 20, and we're gonna do the exact same thing. We're gonna do the opposite. So because we want to isolate the r,
Right,
so we take which is the 20, and because it's a division, we're gonna do the opposite, which is a multiplication. So times 20, and we do that to the opposite of the equation, times 20. And then we cancel over here the 20s. It leaves us 20 times 1 equals 20, so r is equals 20.
all right, that's correct. So if you heard Jacob, you saw me write it, that's exactly how you want to approach that problem. Does that, thank you, Jacob.
Thank you, sir. Thank
Yeah,
you.
well done on that. And George, did that help?
Yeah, it helps. It helps. I'm through it. Yeah.
All right, perfect. All right, so any other questions from this worksheet?
Yeah, you know that what I believe, like, let me say the number 15 is easy. I think it's easy question. So some of those things where we have the answers on the left, that's why I always have problem.
Okay, all right, Salvador, you're trying to say something too?
Yes, Mr. Ray. So like this one that Jacob was talking about, I understood this one. I'm having a hard time with the really long ones, the ones that you have letters on both sides and numbers on both sides with parentheses, like that 20. I've been doing 20 over and over, even though you did it. I believe it's on the other worksheet. And,
the other worksheet.
Yeah, and it was you know, I did 20, 18, and I've been working on them, and I think the process of that is what gets me. With the smallest ones like this one, I could do. With the longer ones, I have a hard time.
So with the longer ones, first thing you want to do always is to simplify. That's your first step. So simplify, and simplify is a generic term, which means you basically are trying to get it as simple as possible, which means you could be distributing, you could be collecting like terms, etc., right? Anything that gets you down so it looks as simple as it does in the other worksheet. Once you get it down to its simplest terms or simplest expression, then you want to go about to solve it. So keep that in mind. For each of these questions, you're trying to get it condensed. So that means you want one variable. You don't want to have 2 or 3 or 4 variables. You want one variable that you can narrow it down to. P equals something. So you want 1P, 1A, 1N, etc. All right, so you said number 20, was it?
Yeah, and you already did it on our last class, Mr. Ray. I just, you know, yeah, even you already done it. I did it and it came up, you know, a couple of times, but I had to go back and check it again.
Okay, yeah, this one, I mean, it's a pretty longer one, of course, and that's why I think I did it so that you can see what the hardest one looks like. I remember when I was in school, the teacher would do the easy ones and then leave you with the hard ones. You're like, what? So I try to do the opposite, do at least one of the hard ones. But I'll go through it again. It's always good to see it because this is more like what you might get on the test. And if you could do this, you should be able to do the easy ones. So because we would first simplify, what should we do?
Go ahead,
We
George.
need to multiply. We use minus 5 times 1 will be -1. Yeah.
Okay, that's correct. We're going to multiply in there -5 times the +1. It's going to give us -5. And -5 times the -5x gives us subtract or -25x. And we do the same with the next expression. We're going to multiply a +5 times -8x. And remember, number with number, variable with variable. So 5 times -8 is going to give us -40x. You could just write it as subtract. And then you multiply in again. 5 times -2 gives us the -10. And then on the far right, those are like terms. So you could combine those. And just be careful of the negatives. This is where your understanding of integers comes in. You have -4, and you could say X for dollars. -$4 minus $8, so you're $8 in debt, means -12.
I have a question.
Yes.
So I was trying to write it down because it throws me off with the signs. So right where we have -5 times 1, -5. -5
right there. Yeah, you're
times.
correct. Positive.
Awesome. Good. It was
Yeah.
confusing me. Thank you.
Yeah, I didn't
Okay.
catch that one. Thank you, Jacob.
Thank you, sir.
And let me just
And
make sure I
then-
didn't do that anywhere else. All right, so yeah, that looks fine now. And thanks for that correction.
Mr. Ray, then the last stage, -4 -4x minus 8x. I hope it's supposed to be 12x square.
Right, that's only if you're multiplying. The only way you get a square is if you're multiplying, because a square implies area, length times width. And so that's how you get the square. It's actually named off of the area of a square. So when
Only
you're
when-
adding or subtracting, it's impossible to get a square thick perimeter.
Okay, thank you.
All right. So now that we've done that, we want to collect the like terms. And so first on the left side, on the right side, there's nothing to collect. So we collect any like terms that are on the left side. So what are our like terms that are on the left side of the equation?
I think 25x
25x
minus 40x.
All right, so 25x minus 40x. So you want to do that. How many x's would that leave us with?
1, which is a -12x.
-15x.
Okay, I heard the correct answer. I wasn't sure what the other one was, but 25x subtract 40x, if we were to do those two together, that's going to give us -15x,
Okay, yeah.
right? And then there are two other like terms. I think this is what I heard from, I think Latavia might have said it. Sounded like you said -15. I think I heard a -15 there. So if you combine those two together, you would get -15 equals to -12x. So -5, -10 gives you the -15. All right, so then after that, you want to have all your x's on one side. Remember, that's part of simplifying, and the positive values on the other side. So if we do that, we want to move our x's around. It would be easier to move this negative over. It doesn't really matter, but this would be the easiest move instead of doing steps twice. And so if I plus 15x there, do the opposite operation, same term, and what we do to one side of the equation, do to the other. So these will cancel. And on the left, I have -15 is equal to 3x. And then the last step, I want the x by itself. So what would I do there?
Divide by 3.
Can you explain this last, Mr. Ray?
Yes.
Sorry. Can you explain this last step again? Why we went to choosing 15x as, because based on what we're doing before, we were trying to isolate the x. So I would have not chosen that, but okay. Can you explain that last step, please?
Okay, let me just ask what you would have done just to see if I possibly threw you off from last time. What you would have done?
No, not necessarily, but because of these other ones. So we were trying to isolate the variable.
Right. So we
So
want the variables to be on the same side. So we want all the x's on one side, all the numbers on the other side.
okay.
So we need to move the x's over. So I could move the negative 12x over, but then I have to move the negative 15 back. So it would be easier just to move negative 15x to the other side, and then I have all my x's on one side.
Okay, that's why so we do the opposite again.
Right. So we do the opposite sign.
Okay.
But we're moving the whole term this time. So I want
Yes.
the whole 15x.
So what we do to this, I would do to the other, and now we separated them. Okay.
Right. So we do the
Okay.
plus 15x on the left, plus 15x on the right. On the left, now we're only left with negative 15. On the right, negative 12x plus 15x is 3x. And now we do the same thing, opposite operation, which is division. Same number we want to move, which is 3. And what we do to one side of the equation, do to the other. And those will cancel. And negative 15 divided by 3 is going to give us negative 5.
Okay.
So x should equal to negative 5, as long as I didn't make a mistake. I'm a bit tired tonight, so if I do, forgive me. All right, so you should get x equals to negative 5. We could check on that, just go down to the bottom, and yes, that is correct. X equal to negative 5. All right, any questions regarding what we just done? Like that question there basically summarizes everything we have done. Distribution, collecting like terms, solving negatives, everything is just thrown into that one. The only thing missing is a fraction. If a fraction was in there, it basically would have covered the majority of what we've done since the very beginning.
Mr. Ray?
Yes.
Yeah, I'm not trying to throw anyone off, but if we would have chose to bring the 12 over to this side, what would that look like?
Okay, does everyone have this?
Yes.
Yeah.
Okay, so I'll show you in a moment. If you decided to go the other way, it would be a little bit longer. You still get the same answer, but it just takes a bit longer. It's like trying to decide, do you want to take the freeway or take one of the roads to your house? So if you move the negative 12, you get plus 12x, and they'll cancel here. You get a negative 3x over here, subtract 15 equals to 0. Then you have to bring the 15 over because you want the x's by themselves, or you could bring the 3x back, either one. But you see it's an extra step now. So we have negative 3x equals to positive 15, and divide both sides by negative 3, and x is equal to negative 5.
Wow.
So, you know, you still get the same answer, but it's just like driving. It's just, you want to choose the easiest route.
Okay.
So the reason why I knew which one was easier is because the end game is to get the x by itself.
Right.
And I could see with one movement, I could do that. Whereas if I move the negative 12, I'm going to have 2 movements to bring the negative 15 back.
Okay.
Mr. Ray, let's just try number 18, number 13.
Say that again?
Let's try number 13.
Number 13.
Yeah.
Okay, number 13. And looking at number 15, that might have been a better one.
Okay.
Okay, number 13. I'm just going to go ahead and do it. If you want to dictate to me, that's fine. If you look on the left side, is there any simplification that we can do?
I think the only simplification we have minus 6k and
3.
Yeah.
Well, it's nothing we could do over here. So we move over to the right side. And on the right side, what can we do?
We
Multiply.
distribute.
Distribute, right. So we distribute into here. And so we have negative 18, subtract 6k is equal to 6 times 1 is 6. And then 6 times 3 is 18k. All right, so now what do we need to do?
Now we get rid of the like terms.
Right, so we want to get the like terms on one side. I prefer to stay with positive values. So, and I like to stay away from fractions. So I'll show you how to do that soon. But for now, I don't want a negative. So what would be the easiest thing to do to avoid negatives for my variables?
So we choose the left side to work with.
Right, because if I move the left side, I have positive k values. If I move the
Yeah.
right side, I have negatives, and that's where people get confused. So stick with the easier route, and so do plus 6k, and what you do to one side, do to the other. Now you see the negatives are going for the k's, and I have negative 18 is equal to 6 plus 24k. Now I'm running out of space, so I'll do the rest right here in the middle. All right, I want all my like terms together, so I have k's on the right side, so I want my numbers on the other side. And what do I want to move over now?
6.
6, and how do I do that?
Subtract 6.
Subtract 6, and what I do to one side of the equation, do to the other. So both sides will get subtracted by 6. Over here, they cancel, and this is where my integer understanding has to come in. What will the left side be?
Mr. Ray, let me ask something. Mr. Ray.
Go ahead. Yes,
Yeah.
George?
When we look at the equation where we have minus 6k, you put plus. Then at the other side you put plus. At the other side of 18, you put plus.
Right.
I was thinking that there we have minus 6. Then it is.
We have to do the opposite operation when you move things across to the equal sign. Remember, we do the inverse, the opposite operation, same number. What you do to one side, do to the other. So it's always the opposite. The opposite of minus is plus.
Okay.
All right, so we have 24k here. On the left side, what would negative 18 subtract 6 give us?
Negative 24.
24.
Negative 24. Now we need to get k by itself, and how do we do that?
Divide.
By 24.
Divide by positive 24. Let me just let Dina back in. And what we do to one side, do to the other. Remember, it's the opposite. Reason why we divide, because it's 24 times k. So the opposite would be dividing by 24. Okay, and then we balance it out by doing it to both sides. So we get negative 1 is equal to k. And remember, you could check your answer down bottom. For number 13, we get negative 1, as you see there. And that's correct. All right, so that's how we do those ones. Hopefully it's making more and more sense. If you did not finish this worksheet, you want to try to finish it between now and Thursday. We do need to go on because time is ticking and December is almost here. And once we master algebra, geometry is really a breeze. Geometry is just knowing how to apply the formula to the shape, and then everything else is algebra. They literally just use algebra formulas to work out geometry. So if you master geometry, the only reason you won't do good in geometry is if you don't know what the shapes are. But if you can identify the shapes, they give you a formula sheet, and you just use the formula sheet accordingly. And it's all algebra. So you master algebra, units 3 and units 4 becomes very easy, which is the bulk of the test. And you should hopefully know unit 1 because you need to use unit 1 in unit 3. And then unit 2 is really easy to learn. You can do it within a week or less to learn unit 2. All right, so let's go ahead. We're going to move on now to the word questions in the book. And so just got to switch over. And so if you go to your student book now, on page 52. Did we ever do number 1 on page 52?
No, I don't remember. Sorry.
No, we did.
Okay, perfect. So we're starting now with the word problems. And with word problems, that's basically what we did in lesson 1. What we're doing now is combining lesson 1 with what we just learned on how to solve equations. So lesson 1, we learned how to read a question and formulate an expression using these terms right here: 4 more than a number, 5 less than a number, the product of 6 and x, etc. Right? We learned how to do that. So now we're going to combine that with solving equations. Now, it's one thing that's not written in here. For equations, there's a key word in equation. What is the word in equation that differentiates? Equals, right? With an equation, you have an equal sign. So when you're reading the question, you're looking for something that signifies equaling, right? To be equivalent to something. And so words like is, if I say he is a boy, I am saying whoever the person is equated to being a boy, right? That's what the word is represents. Or was, you know, I was a boy. I was equal to that at some point, so I can still put equal. So you see the word is or was, that's indicating equivalency. So that means you would read the expression like we did in lesson 1, and you're looking out for terminology that signifies equivalency. Another term that you might hear is total. If I say that I went to the store and I spent $5 on 3 objects, that means those 1, 2, 3 objects added together will equal the amount of money, right? Because the word total is signifying equality. So that's what you want to do when you read these questions. And the first thing you want to do is try to see if you could create a verbal model, very similar to what we were doing before. You're trying to set up what is happening. How many bills do I have? How many dogs are in the question? How many cats, etc.? And then what does it total up to? So when I read that question, look for those key terms. It's like that in everything, in all of algebra. No matter how difficult the algebra gets, you want to create a verbal model so you have an understanding of what's happening. All right, so let's read through this and see if you can pick it up. Levi paid 2 bills. How many bills?
2 bills.
2.
That's really important. The cost of the 2 bills was 157. What does that was indicate?
Equals.
Equals. So already you have a basic understanding. Can anyone say what that basic understanding of the bills and the total is?
That 2 bills
Is
equal
to
157.
And that's what you want to write out. That's exactly correct, right? We have bill number 1. I don't know if you want to say B1, but bill 1 plus the bill 2 is equal to $157. That's your verbal model right there. And normally we write it out in words. So let me do that. Normally we write it out in words so that it's easier to see. So you might say the first bill plus the second bill is equal to 157. Does that make sense?
Yes.
Yes.
All right, so now that we have that part, we just need to come up with variables for the first and second bill. And that's normally easier once you set up the verbal model. So the second bill was $5 more than twice the amount of the first bill. Now remember, we were doing that last time in lesson 1. So let me read it again. The second bill was $5 more than twice the amount of the first bill. So in order to do this, everything is based off of the first bill. If I don't know how much the first bill is, I can't figure out what the second bill is. Does that make sense?
Yeah.
Because the second bill is $5 more than twice the first. So that means I need to have something to represent the first bill. The second bill is dependent upon the first. If it's dependent upon the first is what we call the independent variable. And the independent variable we always represent by X or some variable, but typically X. So that means the first bill would be X. Does that make sense?
Yes.
Why is it X? Does anyone want to repeat? Why did I choose the first bill to be X?
Because it's without the figure.
Right, without it, we can't get the second one. The second one is based off of that, so it's X. All right, so now we can do the second bill. How do we write the second bill? Well, state it there. So what does it state there for the second bill?
The second bill is $5 more than twice the amount.
Okay, so how could we write that based off of what we were doing?
2x plus 5.
All right, 2x plus 5, right? 5 more means to add 5, and 2 times means 2x. So we have 2x plus 5 represents the second bill. And we already know, because we did a verbal model, that this equals to 157. And it looks like that's all they want you to do. So number 1, what is the answer?
C.
I heard C and D,
D.
which, all right, D with
Oh,
the
my bad.
positive. Yeah, be careful there. They do that on purpose, so you got to be really careful. And the sad thing is you don't submit your work, so they can't even see if you meant to do D. So you got to be really careful. Sometimes they might throw that in A, and that can throw you off. So always check your work carefully. But yes, that's how you do it. And you'll see that many of those questions, no matter how high you go, Algebra 1, Algebra 2, trigonometry, calculus, follows the same concept. Come up with a verbal model of what's happening, and then start to represent each of those models or each of those parameters with the appropriate variables. All right, so you see this concept continued no matter if you're doing it in the workbook or in the student book. So let's go ahead and try some more. Number 2 is a little bit easier depending on your understanding of, what did I just do? Right. Okay, so number 2, like I said, is easier if you understand some of the words. So does everybody understand the word consecutive?
Consecutive.
One after another.
One after the other, right? So consecutive means right after each other. So 5, 6, 7, 8, those are consecutive numbers. Now this is important because number 2 is a question that if you went to any high school or college, you will see these questions. They always pop up. They're very popular questions. Okay, Susanna was just coming back in. All right, so let's go over how to do this one. First of all, it says the sum. What does the word sum mean?
Addition.
Addition. The total sum.
Addition, right? So we're going to add how many numbers?
2.
And to what type of numbers?
Consecutive.
All right, so that means I could say first and second, right? So I could say the first number plus the second number is, what does the word is mean?
Equals.
Equals 15. So now I just need to represent what the first and second number are. So what could I represent for the first number?
X.
X, right? Because that's the one that everything is dependent upon on this equation. Sometimes the second one is your X, so you got to be careful. But how can I now relate the second number to the first number? What is the relationship of a consecutive number?
So it'll be so it'll be 2. Would it be 2?
Well, it would be 2 if the first one was 1. But what is the relationship between 1 and 2? Like I know it sounds simple, but that's literally it. What is the relationship between 1 and 2, or 7 and 8? Or 10 and 11?
It's an addition up.
Addition of what?
Consecutive numbers?
Addition of 1, right? So it means it's 1 more than what?
Than that same one.
And what do we call that one?
X.
X. So 1 more than X.
One.
That's literally how you can write it. 1 more than X.
X plus 1.
X plus 1. And if you put some numbers in there to try it, if X is 5, then the second number is 5 plus 1, which is 6.
Okay, yeah, that's true.
Right? If the first number is 9, then the second number is 9 plus 1, which is 10.
Gotcha.
Now this helps you because sometimes they have questions like these. They might say odd numbers or even numbers. And even numbers, it's every 2 numbers, right? So if you have 5, then it would be 5 plus 2, which is 7. If you had 4, then it's 4 plus 2, which is 6. So with even numbers, you would have had X and then X plus 2 to represent that it's a 2 gap. Yes, George.
Yeah, I was thinking that the X plus 1 should be inside parentheses.
Yeah, you can, but whenever you're separated by plus signs, you don't need the parentheses. The parentheses just help you to understand that the x plus 1 goes with the second. So you can have them, but for this one, you can see that's not in there. So for this one, they want you to simplify it. For number 1, they didn't ask you to simplify it, but here you can see that you're going to need to simplify it to find your final answer. So we need to collect the like terms, and if we collect like terms, what will we have?
Is it X?
Got 2x.
We have 2x plus
1 equals 15.
15. And which one is that?
B.
B. Now be careful, because whenever I teach this, people are like, I said 2x. But if you notice, 2x is everywhere. And if you would have put 2x here, you would have had 3x equals to 15.
Wow.
Or 3x plus 1 equals to 15, or all sorts of numbers, right? It's not until I let people do it on their own, that's when you start to realize, oh, man. So once again, you want to get the basic gist. You want to get the verbal model. What is happening in the question? And then replace your model with the variables. Listening carefully or reading carefully to what those connections are. All right, the next few, you don't really need algebra to do 3 and 4. So I'll let you guys just go ahead and try those. You can use algebra. I'm going to do it by algebra for 3 and 4. But you guys can go ahead and try it anyway, any method that you can think of to solve for number 3 and number 4. So go ahead, try that. You can send your answers in once you get it.
So we're doing 3?
3, and then once you're finished, number 4. And once again, you can use algebra or any method of solving that you know.
Okay.
Mr. Ray, how can I send my own answers?
Say that again?
My answer, how can I send it to you?
Yeah, once you finish, just send it in the chat. Remember, for these two, number 3 and number 4, You can do it without algebra. So if you're trying to do it with algebra and you're having trouble, you can try to do it just by thinking through it. But it would be good to know how to do it with algebra.
Mr. Ray, I'm trying to send the answer privately, but I can't see your picture to click on it. Maybe I just sent
through the arrows.
Everyone. Let's see.
All right, you got me.
Stream. Oh, wait.
Clemente, is that the order of your questions, number 3 and then number 4?
Yes, it is.
Okay, thank you.
Times 2.
Less than 2 times.
I know the answer, but I'm having a hard time translating it into an algebraic expression.
Okay, so you're able to do it just thinking through
Well,
it?
yeah,
Yes.
I'm having a hard time expressing that half with that x. It's messing with me. I know the answer now, but
So
trying to
look,
figure-
you
yeah.
might be able to find an answer, and I think we did something like that before, didn't we? If you remember how we did number 9 on page 51, that will help you. Right, it looks like my answers have slowed down now, so not sure if everyone is wanting to give an answer in. I didn't get one from everyone.
Less than 2 times the cost.
To those.
All right, so I'm gonna start number 3. All right, a good bit of you guys got the answers correct, so well done if you got a correct response there. Number 3 says the cost of an adult ticket to the ballet is $4 less than 2 times the cost of a child's ticket. If an adult ticket is $20, how much is a child's ticket? So like I said, you could do this one in your head, but you do want to practice on knowing how to write it out algebraically, because as they get more complex, it's going to be hard to do it in your head. And when you start writing it out, you can get a bit confused, and this is where algebra can really come in handy. So let's go over this one, the cost of an adult ticket. So that means an adult ticket, which I can represent with A, is, so the adult ticket is, so A equals, the adult ticket is $4 less. We learned that means to subtract 4, then 2 times the amount of a child's ticket, or 2C. And so basically my equation is the adult ticket is equal to 2 times the child's ticket, subtract 4. Now, for those who do it in your head, you're literally doing the algebra expression in your head. It's just knowing how to take what you do in your head and write it out. And even when you do it in your head, you're actually following the order of operations. Because if you don't follow the order of operations, you get some crazy number. So if you've done it in your head, you did 2 math skills. You did order of operations in your head, and the second thing is you did algebra in your head. And so the key is learning how to take what you can do up here onto paper, especially when it gets more complex. So now that we've done that, it tells you that the adult ticket, not the child's ticket, the adult ticket is $20. So that means that we have 20 is equal to 2C subtract 4. So that's what our equation is, what we can use now to find the child's ticket, sorry. So remember, we can solve that pretty quickly. Start with the weaker operation, we do the opposite. And so the opposite of the weaker operation is plus. We do the same number, and what we do to one side, we do to the other. These will cancel. I'm gonna write everything below this paragraph. 20 plus 4 is 24, and then we can divide both sides by 2. And that gives us an answer of 12. We got 12, and that's going to be choice C, $12. All right, so once again, we used our skills from lesson 1 in unit 2 by reading it carefully. The adult ticket is, so that means A equals $4 less than, we learned that means to subtract 4, and 2 times the cost of the child's ticket, well, 2C if we represent C as the child's ticket. Once we get that equation, we could go ahead and solve it, and we get C equals to 12. Any questions for number 3 using algebra?
No.
All right, so let's move on to number 4. For number 4, very similar. Like I said, I'm going to do it using algebra. You could do this one in your head as well, but we are trying to learn how to do it algebraically because these questions can get more and more complex. And that's where algebra can really, really assist in making sure we can solve something. So it says Stephanie's age is 3 years greater. So think about what that means. 3 years greater than half of her sister's current age. So first of all, what does 3 years greater mean?
Plus 3.
Plus 3.
Now it says Stephanie's age. So
I'm sorry.
represent Stephanie with S. So Stephanie's age, or you could just put A for age. Stephanie's age, I'll just put S for Stephanie's, is equal sign 3 years greater. So I could say plus 3 or 3 plus something. It doesn't matter the order for addition, but something plus 3, then half of. Remember, what does the word of mean when you're doing fractions?
Multiplication.
Multiplication. So I'm saying half times something. Half times what?
Half time current age.
Her sister's current age. Do we know her age yet in the sentence? I know we know it later, but right now in the sentence, do we know it?
No.
Not yet, right? So we could put half A for half of her age. And so that's our equation. Stephanie's age is equal sign 3 more than half her sister's age. So that's our equation, but they give us her age. They say that her sister is 24. So we can substitute 24 in there. Remember, when we substitute, we want to put parentheses there. And so now we can find out half of 24. What's half of 24? 12. And what's 12 plus 3?
15.
15. And so now we have our answer of 15. Does that make sense?
Yeah.
Any questions for number 4?
Okay. Let me write that down.
So once again, if you write it, and if you want to write it in order, you can. You could have said Stephanie's age is equal sign 3 years greater than half of her sister's age. If you saw that, I literally wrote it exactly how it's read. I mean, that's what algebra is. I'll do it one more time. Remember, the word is indicates equal sign, and when you use a fraction or decimal or percent, followed by of, that's multiplication. So if we did this again, Stephanie's age is equal sign 3 years greater than, greater is plus, half of means to multiply. Her sister's age we can represent with A. So we have literally written out the algebraic equation for what we just read. Sister equals 3 plus half her sister's age. And then solve once you substitute 24 into A. All right, I'm about to erase this. Does everyone have it?
Yeah.
Yeah, I had it.
All right, I'm clearing in 3, 2, 1. All right, number 5, I'm gonna leave you. Number 5 is pretty straightforward too. But looking at the time, let's go ahead to do number 6. Number 5 is very similar to that. I'll just do number 5 for you guys. No, go ahead, do number 5. It's better that you try to do something and this is easier. So try to see if you could do number 5 now using algebra. And try to do exactly what I said. Just write it out exactly as you read it.
Two more. 1/3, which is 2x. 2x.
Nice.
That sounded like confidence. I'm hoping that's the
Yeah,
correct
that's what I
answer.
mean. Ray.
Say that again?
No, that's what I mean. It just feels great to be able to understand something. So I just
All right, that's what we want to hear.
I was so messed up the last 2 weeks. So frustrated.
Well, yes, it could happen. I've hit that frustration wall. Okay, thank you, Raymond. Just remember, you could catch the upload. So Jacob and Marisol, you guys see if you could do number 6. Number 6 is going to up the ante a bit, very similar to number 1 and number 2. So see if you can do that. A verbal model can really help as well.
Can you scroll it up a little bit to see the options? Thank you.
You're welcome. Okay. All right, so I'm gonna go ahead and start number 5. Does anyone want to dictate how to do number 5?
Eh,
I can give it a shot.
Okay, Jacob.
So, okay, number of cellos in an orchestra is equal to 2 more than 1/3 of the number of violins. So I just used X. I'm trying to find out how many cellos there are, if there are 24 violins. So I said I put X equals 2 plus 1/3 of the violins. I represented it with V. And then because it is giving me the number of violins, now I replace the value 1/3 times 24, and then I just do the equation, and it gave me 10. So 2 plus 24 times 3. No, sorry. Divided by 3.
Mm-hmm.
24 divided by 3 gave me 8. 2 plus 8 equals 10.
All right, that's correct. And like I said, you can use any variable. So Jacob said he had used X. I just used C because C stood for cello.
Cello, yeah.
And just like he read it, number of cellos, C, in an orchestra is, that's equal. So if I wrote it here, that's C, cellos, is equal to 2. So I put 2. More, that's plus sign. 1/3, that's right here. 1/3 is 1/3. The word of, multiply, and then violins, V. Right? So, I mean, normally it's written right there for you. It's just knowing how to pick it out. So the number of cellos, C, in an orchestra is, so that's the equal sign. 2 more, so I put 2. More than, plus, 1/3, I write 1/3. The word of means multiply, and I'm multiplying the number of violins, so I could put V. And I'm done. C equals to 2 plus 1/3 V. And remember, we learned that 1/3 V times V can be rewritten as V over 3 as well. So just keep that in mind if they're asking you to write out an equation and you don't see that. Remember, these two are the same. They are equivalent. And so just keep that in mind if that's choice selection. Sometimes that throws students off because they don't see their choice. All right, and then as Jacob said, they give you 24 violins, so you could just substitute that in. 1/3 of 24 is 8, and 8 plus 2 gives you 10. Some of you have sent me 8, and I'm thinking you did that. You did 1/3 of 24, but forgot to add that 2, which would have gave you 10. Any questions on number 5?
No.
I kind of got stuck right there. I did the first and the second step, but
Right.
I kind of got confused after that.
Oh, okay. So, but did it make sense now?
A little bit. Can you explain it again?
Okay, so from the beginning or from?
Just the third step, like after the 20, like I did the first step, which C equals 2 plus 1/3 V, and then C equals 2 plus 1/3, and then the 24. But then after
Right.
that, I get stuck.
Okay, so once you get here, that's when you do the order of operations. Remember, the order of operations is parentheses first, and by parentheses we mean what's inside, so groups or quantities. So there's nothing I can do with that. So exponents, there are no exponents, and then multiplication or division, whichever one comes first. So I multiply 1/3 times 24. Now, if you have your calculator, you could do that right in the calculator. If you don't, then you could say 1/3 times 24, and 24 can be written as a fraction as 24 over 1. And if you multiply straight across, 24 times 1 is 24. 3 times 1 is 3. So in essence, what you're doing is saying 24 divided by 3.
Yeah.
And if you know your multiplication tables, that should hopefully trigger very quickly. If you know your 3 times tables, the 24 divided by 3 is 8. If not, you have to do long division on the side, or just use your calculator if you have the calculator usage. So 24 divided by 3 is 8. And then the next step after that is addition or subtraction. And it's addition next, so you say 8 plus 2, which is 10.
So that 2, you got it from, you're just moving that down?
Yeah, what you're seeing me, I'm doing it line upon line. So I'm doing the first line, and then I'm writing what happens if I substitute 24 for V. Then I'm writing what happens when 24 times 1/3 is 8. And then I'm writing what happens when 2 plus 8 is 10. So it's a progression. that's going down. So that 2 is just coming down from the very top.
Okay. Okay. Okay.
All right. Any other questions for number 5? All right, let's go ahead and try number 6. Number 6 is kind of a combination of what we've done. It looks very similar to number 1 and number 2. And if you remember, in number 1 and number 2, I talked about a verbal model, trying to see how many items am I adding or subtracting, what does it equal, and then using that to create the equation. So for number 6, if you haven't started number 6, go ahead and try it. See if you can write out what the equation is, and then you're going to have to simplify it. And once you simplify it, then you should be able to see what your selection is. So remember, first step, try to create a verbal model first. What is happening? Do I have a total? Am I adding or am I subtracting? Or even multiplying or dividing. Most times at this level, most of your questions will be adding or subtracting. it looks like this one might be causing a little bit more trouble. So, oh wait, sorry, I have an answer just came in. That's correct. All right, so I give a few more moments just in case anyone else wants to try it. I just got a correct answer in, Latavia. This is, you know, very similar to what we did in number 1 and number 2. All right, another one. So first thing I'll say is, can we come up with a verbal model? How many, well, let's read through the question. It says, Caroline has twice as many yoga classes as aerobic classes. So how many types of classes are there?
There's 2 different types of classes.
2 different types of classes. So how could I represent in terms of a verbal model?
Represent Caroline as X, and at least that's what I did.
Say that one more time. It sounded like you're far away.
Sorry, I represented Caroline as X, and then I add the 2 classes. So I said X plus 2X.
Okay, so you're a little bit ahead, but that's on the right track. You have yoga classes, and then you have aerobics classes. And I spelled that wrong. I thought it looked wrong. And aerobics classes. And Latavia is on the right track. She's going to go right to the end. That is correct. So you got yoga plus aerobics, right? Does that make sense to everyone? We have 2 types of classes, yoga and aerobics. How many classes is she taking all together?
3.
3. Remember I said when you have a total, that's the same as saying equals to, right? Because you're adding up how much they equal to, or you're finding the total. That's what the total literally means. So that's my verbal model. My yoga classes plus my aerobics classes will give me the total amount of classes that I have, 3 classes. Now, typically I'll write out more, but I don't have much space. So I would have put yoga classes plus aerobics classes equals to 3 classes. So now we just want to find out what the arrangement is. And so we go back to the question.
Say that again. How do we have 3 classes, or because of the 3 yogas?
Yeah, it says it's just taking 3 yoga and aerobics classes. Now that can sometimes throw people off because it's like, is she taking 3 yoga and 1? But when you look at the language correctly, it's saying that it's a total. She's taking 3 yoga and aerobics classes. So altogether, they add up to 3.
That's where it confused me.
Yeah, sometimes those can do so, but if they don't give you a number directly following or in front of preceding aerobics, then you can safely assume.
Yeah, for some reason I thought it was 3 yoga and 3 aerobics.
Oh,
so,
okay, yeah. So for that one, it's saying,
I was misreading it.
yeah, it's that language part there. That one's always tricky with the word problems. Sometimes they rearrange it. But this one here is specifying that there are 3 yoga and aerobics classes. So the
3
2 of them together equal to 3. All right, so now we want to see what the relationship is so we could decide which one is X. So which one would represent our X?
Aerobics.
Okay, and why aerobics?
Because we have, well, no, it says that twice as many yoga as the aerobics.
Okay,
so the yoga times 2 will give me how many aerobics that is.
Right, so if we have 5 aerobics classes, then we have twice as many yoga, so 10. If we had 7 aerobics classes, we have 14 yoga, right? So that's relationship, that one is 2 times the other. And here's an example where they are not in the first order. So we have 2x plus x equals to 3. And now we can combine our like terms. So what's 2x?
A.
All right, so I hear another answer. So 2x plus x is 3x. And
Nice.
that's equal to 3.
Absolutely.
And so that's our answer there, A.
Yeah.
All right, now remember, just in case anyone has to go, what you want to work on between now and Thursday, I'll repeat it again at the end of the class, but what you really, I can't stress how much you need to do so, What you want to work on is the workbook pages 62 to page 65. You have to master this in order to do well in algebra. I can't stress it. This is like one of the most important sections, lesson 1 and lesson 2. Now, I didn't get that many questions in lesson 1, but I gave a similar pep talk to my students in the morning, and they gave me a lot of questions today because they're like literally a class ahead of you now.
Mr. Ray, you say from
What
page
pages were again, Mr. Ray?
They had it. Say it again.
What pages were they again?
Page 62 to page 65 in the workbook.
Okay.
So that's the homework connected to what we're doing now. And it's really, 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 really important that you guys work on this between now and Thursday. So, and whatever questions you have, please be ready. I would not be surprised if I have a lot of questions. And I do not mind going over it, because if you can master algebra, like I said, it makes everything easy because everything's built off of this. And the better you understand the foundation, the easier it is to apply more layers to your foundation. All right, so let's move on to number 7. And we did something similar in lesson 1. You may remember in page 51, number 6, we did something similar to this, number 6 and 7. We did it with a rectangle. Now we're doing it with a triangle, and now we have an equation equals to something. Whereas before we just did the expression, now we're doing the equation. Remember, an expression doesn't have an equal sign, as you see here. The moment it becomes an equation is when you set it equal to another amount, a different amount. All right, so let's see if you guys could do this. The perimeter of the triangle is. Think about what is means. The perimeter. What does perimeter mean? Of the triangle is 16.5 feet. Then they give you the dimensions of the triangle. And then number 7 says, which equation can be used to find the value of A?
But let me say, for the perimeter, the formula is length plus breadth times 2.
Say that again?
The formula for perimeter should be length plus width times 2.
No, remember, perimeter is just to add up all the sides.
Of the sides, yeah.
So all you have to do is add up all the sides. If I had 3, 5, 6, you say 3 plus 5 plus 6.
The answer is A.
Okay, I hear A as an answer. And I have an A in the chat. So another A just popped up in the chat. A's are popping up. Now, I don't even remember the answer. I didn't do it in my head. And that is correct. Yeah, I just did it in my head. And I think most of you guys are seeing the, I mean, you don't really have to even finish it. You should just see by the A's. If we're going to be adding up all the sides, then that means I'll be collecting like terms, right?
Yep. Yep.
How many A's are there?
5.
5 A's. And that right there should tell you your answer, because there's no other way to lose 5A or gain a 5A. So before you even get to the question, you could see the answer, hopefully. But for those who may not see it right away, what we want to do is remember what perimeter is. Perimeter means to add up all the sides. So if I started here, I would say A plus 2A plus 2A subtract 1. And that gives me the perimeter. But the question tells me what the perimeter is actually equal to. So I don't have to write equals to P for perimeter. I can literally write 16.5. But hopefully, I remember what we've been taught, that whenever I have an expression like that, I should always simplify. And I should be able to notice that's not simplified. I can make it more simple by collecting like terms. So A plus 2A, remember A by itself is 1A. Remember we talked about that before. We don't say, look, there's one person, right? We say, look, a person, or look, a man, a boy, a girl, right? We don't say a one girl, one boy. We just say it, and everyone knows what we're referring to. So the same with A, we don't need to write the 1. So we just add them up. A plus 2a is 3a, plus another 2a is 5a. And so we have 5a subtract 1 equals 16.5. They don't actually do anything else. They just want to know what the equation would be. So that would be selection B. And hopefully that makes sense. A good bit of you guys just threw out the answer, which means you saw it one time. That's great. And hopefully that boosts your confidence. And the more you practice, the easier it gets. Just don't renege from your practicing. You are human. If you stop practicing, you will forget until you master it. Once you master it, then you just have it. But as you're learning, you have to continually practice, just like anything else, whether you're learning to play football, soccer, basketball, golf, whether you're learning to write computer code, whether you're learning a new job, you're going to have to rehearse, right? That's just life. You're learning to play piano, guitar. You have to practice. If you don't practice, you just don't get success. So that's why I say about carving out the time. Any questions for number 7?
No, sir.
All right, number 8. And we're building up for number 9. Number 9 might take some thinking. So number 8. 4 times the number is 4 less than 2 times the number. Now that may sound confusing, so break it up step by step. 4 times a number is 4 less than 2 times the number.
So 4x equals 2x minus 4.
Okay, that's just, we're on borrowed time. I'm actually just going to take that. If you guys heard it, that is correct. 4 times the number, 4x is equal sign 4 less, so you're subtracting 4, then 2 times 2x, the number, which is x. And now they ask you to solve it. So well done, Jacob. That's literally what you're doing. Now you go ahead and solve it. So see if you guys can get the correct answer now that the equation is set up.
So does it matter, like, because I had put it exactly in order. I did 4x equals 4 minus 2x.
Okay, so that you have to be careful with subtraction. And I kind of mentioned it slightly. I had said you can write it in order most of the times, right? But I said it kind of quiet. When it comes to subtraction, you have to be very careful. So when you see the word less than, remember, I'm not sure if you were here when we talked about that, but with subtraction, you have to make sure the order is proper. So you're subtracting the 4 from the 2x.
Oh, okay.
That's what less than means. So if I have $4 less than you, and you have $16, I have to be careful not to say 4 subtract 16. What I'm really saying is 16 subtract 4, because I have $4 less than you. So
Okay.
the order is really important there when it's subtraction. With addition, it doesn't matter. You could just write it out any format. But with subtraction, the order does matter. All right, I see some answers popping in. And don't worry about my typo there, but those 2 are correct. Okay. Now remember here, we have 2 x's. So you have to always analyze it. Can I simplify it first? If you can, you have to simplify it first, and you might find yourself going around in circles or getting the wrong answer. So always check to see if you can simplify. If you can't simplify, then you just go ahead and solve. But if you can, you have to do simplification first, or else you will not get to the answer. time? Okay, we're gonna go ahead and start this one because it's almost 7:30, and I do want to make sure we finish this, and then possibly do a few from the next two. I do want to try to get to lesson 4 as fast as possible. So let's go ahead and look at this one. Just responding to one more person there. All right, so to solve this, we want to collect the like terms. What are the like terms here?
-4.
Well, -4 is all by itself.
The x's.
The x's, right? -4 is all by itself. There's no other integers or whole numbers there. But we have two x variables, and we need just one to solve. That's what you want to remember. If you're trying to figure out if you can simplify, you want to have one of each type, right? You want to have one set of x's, one set of numbers, etc. And so you want to simplify down as much as you can. If you don't, you're going to violate rules in order to solve, and then you're going to get the wrong answer. You have to, you literally have to simplify in order to solve. So that means I need to combine these terms together, combine my like terms, and I want all the x's on one side of the equation. So what should I move?
I went with moving the 2x over to the 4x.
That's correct. That's the
Over to the
fastest way.
Yeah.
Remember, if you do the other way, it'll just take more steps. So the 2x's will cancel, the two 2x's will cancel, and then 4x subtract 2x will give us
2 minus 2.
Again, positive 2x.
2x. Positive 2x, yes.
Depending on how you wrote it out. And then you have -4 here. And now what do we do to find the x by itself? We divide both sides by 2. And I'm just going to put this 2 underneath the paragraph there. -4 divided by 2. The 2's will cancel. And what's -4 divided by 2?
2.
I heard somebody say it. -2 is the correct answer. So B, and many of you sent me the correct answer of B. So once again, starting from the beginning, you have to set that equation up and solve it. Many questions are like that. So we have 4 times a number. 4x is, that's the equal sign. 4 less than, order is important. 4 less than means to subtract 4. 2 times the number, that's where you're subtracting from. So you put 2x there and you're done. Then it asks you what is the number, so you're going to have to solve it. You look at that equation, you realize, wait a minute, I can't start solving yet. There are like terms in here that I have to collect first. Remember the 2 steps that we did with that last worksheet. Number 1, simplify. Then you want to go ahead and try to solve it. So once I simplify by collecting the like terms, I now have a simple equation. 2x is equal to -4. Solve for x, x equals -2. Any questions for number 8?
Yes, Mr. Ray. What I was saying, I just did it the other way, simple equation system, meaning that I divide the both sides equal. That is -4. -4. That's why I did it.
You said you did what with the -4?
Yes, the -4, I just added to be, when I divide the both sides, that is -4, I use it to be +4.
Oh, right. So that's what I mean. You can't solve it because you have 2 sets of x variables that you have to get rid of first.
Okay.
So first step, you have to simplify.
My answer gives me 4 because I did it the wrong way.
Right. So first step, you must simplify first. So simplify first, then you could go ahead and solve. If you've already simplified it or the question is given to you in a simplified format, then you could just go ahead and solve. But you cannot solve until the equation has been simplified. That's what the second worksheet was showing that you have to simplify first and then solve. The first worksheet I gave, everything was already simplified, so you just went ahead and done it. But you want to remember, if you get a scenario like the second worksheet, whether it's a complex looking one or a simple one, you still have to simplify first. All right, this takes us to number 9. Number 9 is a culmination of everything. If you can do number 9 and you can duplicate it on the workbook, because you have questions very similar to number 9, you're really there. You're basically there to set up the equations. We're going to do a few more types of equations on Thursday. And you know, you basically got the main gist of algebra, of the basic part of algebra, because you still got to learn some other stuff. But let's go ahead and see if you guys could do it. Remember, just like number 1, 2, and number 6, you want to create a verbal model. Think about what you have. And is there a total? Once you set it up, look for your variables, your independent variable and your dependent variable. Your independent would just be the x by itself. The dependent variable is going to depend on whatever the x is. It's going to do something like multiply by something or add or subtract something, etc. So go ahead and try number 9. I don't know the answer off my head.
Okay, explain it right now, Mr. Ray.
I was trying to see if other answers would come in, but you can do it right when I tell you to start.
Okay. I don't know if it's like, I was having trouble with the other ones, and it feels like this one, for some reason, it was a little easier.
Well, it's probably because you're learning it and you didn't realize it. Because that's literally what happens. Sometimes the bell just goes off after a few ones, even though we might not have gotten it.
I feel like I was struggling with the other ones for a minute right now, and then this one, I was just like, okay, let me see.
Well, that's good.
Is that right, though?
The one that you sent me is correct.
Okay.
So wait about a minute or two, Dina.
Okay.
All right, Sergio. That's good. Involvement is great. Remember, you want to try to set up a verbal model, see what it totals, and then start replacing your variables.
That's crazy.
All right, it looks like answers have slowed down a bit, and we did want to get to number 10 before the class is over. So let's go ahead and start number 9. Dina, are you ready?
Okay, I think so. Let's try it.
Okay, hold on real fast. I'm just writing back one more person. I'm going to write out as you say it.
Okay.
All right, so you're ready? Let's go.
Okay, do you want me to read the whole problem first?
You can if that helps. Sometimes rereading it helps people to see it. Sometimes a light bulb
Okay.
goes off.
All right, so Jillian collects real political party convention pins. The number of Democratic Party pins he has is 14 less than 3 times the number of Republican Party pins he has. If he has 98 pins in all, how many Republican Party pins does he have? So
All right.
I did 14 minus 3x equals 98. And then I subtracted 14 from the positive 14 and the positive 98.
Okay, you're doing a different way than I have set it up, but let's see what you do.
Okay. And then, well, that gave me the negative 3x and 84. And then I divided by 3. And that gave me the x 28.
Ah, that's interesting. So that just happens to work for this one, but it will not happen every time. But it's just so interesting that
Where I got stuck, it's that we have to add the Democratic and the Republican pins to get a total of 98. So this explanation, it kind of, I mean, it's crazy that it gave the answer, but I still don't.
That can happen. You guys, you might remember that actually happened when we were in Unit 1. I think it was on percentages or ratios, and something like that happened. And I tried to show you guys it wouldn't happen if I changed the numbers around. So something similar here. I mean, it's just, sometimes it does happen that it can work, but I can't let you think that this will work every time. But if it worked on the test, that would be great. So, but let's go over it. But that was great, Dina. That was very close. You got the basic gist down of what you have to do.
Okay.
Let me see something real fast. I just want to see why did it work. 4x, and then
kind of set it up exactly like that, just exactly what she did. Then I realized the answer was negative 28, and there was no
there we go.
negative
Yes.
in the option, but I just
There we go. That's where the error really is, because I was just shocked when I saw it. But yeah, it's negative 28, and that's completely different than
Yeah,
positive.
from in the option.
Yeah. Thank you for saying that negative 28, because this really shows where it is. So you actually get a similar number. I was just trying to see why it was working, but it's negative 28 actually. So just keep that in mind. And although it's a similar one, and most likely you make the guess to the correct answer, it's not correct, and it wouldn't work every single time. Like sometimes something can get very, very close or even be the correct answer, but in the next question, it could come out completely different. All right, so let's go over this one. What we're gonna do is we're gonna break it up. And just like we did with number 6 and what we did with number 1 and number 2. We want to get a verbal model that represents what's happening here. And the first thing is the Democrat Party is being, how many parties is there are in this question?
2 different parties.
2 different parties. And Julian collects them as pins, right? He's a pin collector. So that means if he only has 2 types of pins and they total 98, how could I write that as a verbal model?
By 2?
Say that again?
Divided by 2?
No, well, what if I have...
Oh, 2x equals 98.
Not quite. If I just in terms of names only, just what I have. Say that again?
It's going to be 3x.
Well, no x's, just terms of Democrat Party and Republican Party. How would I write that in terms of just words?
Oh, so it would be D plus
R
plus arrow equals to 98.
Okay, there we go. So the Democrat Party, thank you, George and Jacob. The Democratic Party pins, right? That's how many pins. He has Democrat pins, and then he has Republican pins.
Yes.
And then the Democrat pins that he has, plus the Republican pins that he has, they all equal up to 98 pins. And we're trying to figure out how many Republican Party pins he has. Now, what's interesting is that answer that you guys get, it gives the answer for Democrat. So even if you did 3x subtract 14 equals to 98, your x actually represents Democrat pins. So even though it just miraculously might work in some cases, it's still not correct. It's just amazing that it worked. I mean, that you got the right number. But just think about it, the one that we just did, that x equals negative 28 actually represented for you, if anyone else done that, I know 2 people said they did it that way, that actually represented Democrat pins. But what do they want from this question?
They want to know the Republican
pins. So depending on the type of question that you would have had, you could have ran into a lot of issues right there in itself. So number 1, that 28, that negative 28 should have been positive 28. Number 2, the 28 based off of that method gave Democrat pins and not Republican pins. Does that make sense?
Yes.
And so depending on the types of question, if you have fill in the blank or something like that, you really just have to get it right. So let's go over now what we're doing. Does everybody understand how we get Democrat pins plus Republican pins? Equals to 98. He has 2 types of pins. He collects both types of pins. So that means he has a bunch here, he has a bunch here. And how much does it equal up to?
98.
98, right? So that's the first step. And that's what you're going to have to do for the workbook. And please, please, please practice the workbook questions. Because you can see this is the type of questions that people run into in the GED test. So now that we have one, just like we did here, yoga plus aerobics, remember that? Yoga plus aerobics equals. In the first question, we had the first bill plus the second bill equals. In number 2, we had the first number plus the second number equals. Everybody remembers that? So in this one, Democrat plus Republican equals to the total. You're going to see the same thing in the workbook. Please try them. All right, so first things first, I need to write an independent variable. Which one is independent? Meaning it doesn't rely on the other.
The Republican Party.
Republican, well done. The Republican is your X because that's the one that doesn't rely on anything. The Democrat Party pins do. And how does he state the Democrat Party pins? He says what? Or the question says
14
what?
less than.
3x minus 14.
3x minus 14. So we have 3x subtract 14 being
Plus
added on to x equals to
X.
98.
Oh my goodness. Okay.
And you guys, George
Oh.
and Jacob, you basically just told me how to do that one. But yeah, that's
Yeah.
what
I was just having the hardest time to being able to write it down and understand it like this. To break it down.
Well, the key is just to practice and practice. Do not be afraid of being wrong, but practicing writing it out. I can't stress it more than enough, but you guys really have to try doing this if you really want to do well in algebra. The only reason why you won't do well is if you don't do it. You have to practice writing it out. And so please try the homework. Once again, in the workbook, page 62 to page 65, sorry. All right, so let's go ahead and finish this. We want to collect the like terms. What are the like terms that are here?
X's.
The x's. So 3x plus x is how many x's?
4x.
4x. And then we still have a subtract 14 there, equals to 98.
Minus 14.
All right, so the next thing we need to do is add 14 because that's the weakest operation. Now we're solving. We've simplified. The second step is the simplified form. Now we can solve. When we solve, we start at the weakest operation. We do the opposite operation with the same number. What we do to one side, we do to the other. So that's going to give us 4x equals to 98 plus 14, and that's 112. And now to find the 4x, what would we do?
We divide.
Divide both sides by
4.
By 4.
4. Now, depending on those who wrote out this the correct way, if you wrote it 3x subtract 14, you would have ended up with 112 divided by 3. And if you had done that, you would have saw your answer's not there. You might have rearranged it and got negative 28, which just so happens to work for this particular question, but will not work for every single one. So 4 divided by 4 cancels, and we have 112 divided by 4. And if you do 112 divided by 4, you get 28. Now, what does this X represent? This X represents
Republican.
Republican. Remember, this other X that you were finding actually did not represent the Republican pins per se, because you didn't have the other X there. It just so happens to get close to it. Right? And so once we do that, X will be 28. For how many Republican Party pins does he have? All right, does that make sense?
Yes, sir.
And then to know how many Democratic, now we can just subtract 28 from 98, and that is what the Democratic represents.
Yeah, you could do that. That's one way you could do it. And so that would be 70, it looks like.
Yes.
Yeah, so he would have 70 Democrat pins. And so you can see some they have that choice there too.
Yeah.
All right. Okay, so that's how you would do those ones. Number 10 ended off with a substitution question that's a little bit more complex, and we should be able to finish it in the 10 minutes. Now, we've done some substitution questions in the past, but this one is just a little bit more complicated. But we have learned everything we need to learn in order to do that. We know how to substitute, and we know how to simplify, and we know how to solve. So for this one, it's basically 3 generic steps. Number 1, substitute your y into the equation. Number 2, you can't solve it yet. You have to simplify. Then number 3, once you simplify, go ahead and solve it. So go ahead and try number 10. And can I erase number 9? Or does anyone still need it?
Good here.
All right, I didn't get much answer, so I'll leave it up for just a bit. And then once we start number 10, I'll go over it.
Plus 2. Plus 3x. Equal.
Mr. Ray, is that 2.5?
Yeah.
Yes, that's 2.5.
Okay.
Shit.
All right, so I'm looking at the time and the time that it takes to explain it and stuff. I'm gonna go ahead and start it. Is this one causing some trouble?
No, sir,
Mr.
give us
Ray,
5 more minutes.
Well, we don't have 5 minutes. That's why I said I had to start it. We're like on the last cusp of time. So class finishes in less than 4 minutes. So if I want to get to it, explain it as well, I'm gonna need at least about 3 minutes at the least.
Mr. Ray, no problem. Let us go through that time, even extra more.
But I unfortunately I can't, so I'm gonna have to start it. But the good thing is this is in the workbook. They have, I think, 2 or 3 questions that are very similar to this. But I do also want to add, try to do page 78 to page 81 as well. It comes a little bit later, but it's still the same thing. It just shows you more complicated questions. A lot of them I already gave you with the worksheet. All right, so because of time, I have to go ahead and start this. So we have y is equal to 2.5. So that means wherever we see y, we're going to substitute 2.5 for that y. And if I rewrite this, I have 10 times y, but my y in this case would
No,
be
is my
2.5.
answer negative or positive?
Say that again.
My answer is 1. So I don't know if
I
I'm
think
right.
it is 1. It's either B or C. I can't remember. So I have to do it as I work through. But I know it's 1. It's either 1 or -1, so it's either B or C. So we'll see once I finish it. So if you got 1, you know you're very close.
I have 1.8.
Or
That
you
way I
should
have that one.
Oh yeah, it should be an
I have
integer, and you don't have to round.
Yeah, I
So
have
we have to-
minus 1.8. So that way I have that fraction. So that's
Okay,
why-
so once we substitute everything in there, it should look like that. Now we could go about simplifying. 10 times 2.5. You should be able to do most of these without a calculator. 10 times 2.5 is 25. And then we have minus. We're going to multiply in. 4 times 2.5. Hopefully you know how to do that in your head. Just do 4 times 2 is 8, and 4 times a half is 2, and 2 plus 8 is 10. So that's 10. If not, use a calculator.
That's why I made that mistake.
4 times 2 is negative. So that's negative 4 times 2 is -8. And this should be, I mean, you could have added that together. Let me add it up first. That would be easier. So 2.5 plus 2 is 4.5. So I'm just going to rewrite that one just for time's sake. So that's 4.5, and then -4 times the 4.5 gives -18. All right, -18 plus 3x equals 2. We're going to distribute that in. 5 times 3 is 15. 5 times -x is -5x. Right on the left side, we can simplify that some more. We have 25 subtract 18. That's going to give us 7. And then on the right side, 15 subtract 5x. We want to collect all of our like terms. So bring the x's on one side, the numbers on one side. It doesn't matter where you start. I just don't like dealing with negatives. And so I'll move the -5x over by doing the opposite operation with the same term. What I do to one side, do to the other. All right, so on the right side, this cancels. We have 7 plus 8x is going to be equal to 15. Right, we can subtract the 7, opposite sign, same number. What you do to one side, do to the other. So we have 8x is equal to 15, subtract 7 is 8, and divide both sides by 8. And you should get x is equal to, I got +1, just to be on the safe side, because I am a bit tired. Let me go ahead and check, see if it was -1.
I think
Yeah, +1. So x is equal to 1, B. All right, so once again, I'll just walk through the steps one more time. I skipped a step there, but 10 times 2.5 is 25. In the second part, 2.5 plus 2 gives 4.5. And then the -4 times the 4.5 gave -18. That's, let me see if I could do that. So we have the 25 there, and that would happen. I don't even know where I am now. Okay, I went down. I was trying to turn this thing from being blue. Okay, it doesn't want to be my friend right now, so there we go. So we have the 25, right? 10 times 2.5 is 25. The 2.5 plus 2 is what gave the 4.5. Distributing that in, -4 times 4.5 is -18. And then we still have a +3x. On the right side, 5 times 3 is 15. 5 times -x is -5x. Then what we can do is to simplify. So 25 subtract 18 is 7. And then we write everything else the same. We want to get all the x values on the same side. So I decided to use the -5 and bring it over by adding 5x to it. And what you do to one side, do to the other. It cancels, and we're left with 7 plus 8x equals 15. We want to get all the numbers together now, so I move the 7 over by subtracting it. What I do to one side, do to the other. And then 8x comes down. 15 subtract 7 is 8. And the last step is just to divide both sides by 8, getting x equals to 1. All right, does that make sense?
Yeah, so the where I get my mistake is that I consider that 4. That is the 2.5 times 4. But I ignore the 10y, thinking that it is
Oh, okay.
separate. That was
Yeah,
what I was thinking.
you have to be careful in rewriting. All right, so once again, for homework, what you really want to do, because we have to move just a bit faster to get to the graphing and geometry. But you want to do in the workbook, once again, that's page 62 to page 65. And then I'm going to also throw in there, hopefully you can make the time. I'm going to throw in there page 78 to page 81. So if you can do a little bit of both, would be great. Page 78 to 81 is the second assignment that I'm putting in there. It looks very similar to the worksheet that you were doing before. So if you can do as many problems as you can, even if you do half and half, that's good. Pretty much repetitive in the style of the question. But page 78 to 81 has a lot of fractions and decimals. So you want to expose yourself to those type of questions.
On the workbook?
In the workbook.
Page 70, 71.
So remember, it's 2 lessons. You're doing lesson 2, page 62 to 65, and then lesson 6, which is page 78 to 81. So hopefully you wrote that down, but try to do as many as you can. If you can't do all of them, just try to do some from each. And I'll try to knock out some more on that day. All right. Hopefully you have been practicing. The more you practice, the easier it gets. The easier it gets, the more confident you get. The more confident you get, the better chances you have of increasing your score dramatically. And that's what you want. All right, so I'll see you guys on Thursday, same time, same place.
Thank you.
Thank you.
You're welcome.
Thank you, Mr. Ray. You rock.
Yes, you're welcome.
Thank you, Mr. Ray. Good
You're
night.
welcome. Enjoy your evening. Yes, good night.
Okay, see you Thursday.
Yeah, see you Thursday. Did I hear somebody call me?
No, saying good evening.
Oh, okay, yes, good evening.
All right. Good night, Mr. Ray. Thank
All right,
you.
good night. You're welcome.